Okay, these notes are absolute value inequalities, so it's concept number 2 from quarter 3. And in the last section, we just did absolute value equations. So they're very similar, but also different at the same time. So remember with the equations, once the absolute value is isolated, that's when we split it into 2 different equations where we change the sign of the answer to it. So we're going to do something very similar to that, but we also are dealing with an inequality symbol now, so either a less than or a greater than, and we also have to change it. So in our first example, we're dealing with the absolute value of x is greater than 5. So now we're still going to split this into 2 like we did with the equations. Okay, our absolute value is by itself. There's nothing connected to it. So I'm going to split this into 2 separate inequalities. When I do that, my first inequality looks exactly the same as my original, but without the absolute value bars. Okay, so I'm rewriting it by splitting it into 2, but I'm removing the absolute value bar. So my first inequality is going to be x is greater than 5. So it's going to match the original, but without the absolute value bars. Then our second inequality, I need to, again, take out the absolute value bars. So it's just going to be an x, but now I'm going to flip the inequality sign and change the sign on the number. So now I'm dealing with x less than negative 5. So I flipped the inequality symbol and I changed the sign to the 5 to be a negative. When we do this, this was originally a greater than symbol. So instead of saying greater, we say it as great or to remind us that I need the word or in between these. When we get down to the next one, it's going to be an and statement. So if it's a greater than symbol originally, you need the word or in between these 2 inequalities. So those are my 2 answers. X could be greater than 5. So if I plot this on a number line, I'm dealing with a 5 and a negative 5. So my first inequality is that all of my x values are greater than 5. So that means all of my answers are bigger than 5. So I use an open circle because it does not have an equal sign underneath of it. So that means it's an open point. It does not include 5, and it's everything greater. Then my second inequality is that x is less than negative 5. So I have an open point at negative 5, and all of my solutions for x are smaller than negative 5, so that's everything to the left. Now, if you notice, our shadings go opposite directions. It's because it was an or inequality. Now, in the second example, I have the absolute value of x is less than or equal to 8. So when I split these into 2, instead of saying less than, we switch it to saying less than as a reminder that I need the word and in between these 2. So I have the absolute value of x is less than or equal to 8. So my first inequality stays exactly the same, but I remove these absolute value bars. So I just have x is less than or equal to 8. And x is greater than or equal to negative 8. So my second inequality, I flip the inequality sign and I change the sign on the 8. Again, this was a less than sign to begin with, so that means it's an and. My first one was a greater sign, so instead of saying greater, we say great or. So it needs an or in between. Now, whenever I shade my bottom one, my first solution, x is less than or equal to 8. So if I think about 8 on the number line, less than or equal to it means I shade in the circle, and I would normally be shading everything to the left. But it also has to be x is greater than or equal to negative 8. So that's a solid circle. And it's everything larger than the negative 8. Which means if this is an and, it has to make both of these true. So all of the numbers that are less than 8 and bigger than negative 8 are the ones in between. So if it's an and statement, you are shading in between the two numbers. Okay? We want that overlap. Where are they both true? Okay, now this is just running through what we just talked about. So once the absolute value is isolated, if your inequality sign is greater than or equal to, then it's an or, because instead of greater, we say great or, and your shading is on the outside, so they're going opposite directions. If your original inequality signs are less than or equal to, it's an and statement, so your shading is in the middle. It's in between your two solutions. Okay, now the rest of these are just a lot of examples. What's important is that your absolute value has to be by itself first. Same thing as what we did with the equations, which is true in this case. I have the absolute value of 5k plus 2 is less than 8. So when I split these, because of that less than sign, this is an and statement. So when I split this, my first inequality is 5k plus 2 is less than 8. I make it exactly the same as my original, but I drop the absolute value bars. I need the word and in between these, and my second one is 5k plus 2 is greater than negative 8. So I flip the inequality sign, and I flip the sign on the number. Now I'm just going to solve them both. So I'm going to subtract 2 from both sides. I get 5k is less than 6. And then you divide both sides by 5. So we get k value is less than 6/5. That's one of our two answers. Then I'm going to solve the other one. Again, subtract 2 from both sides. So I get 5k is greater than negative 10. Divide both sides by 5. We get k is greater than negative 2. Now we have to graph both of these answers. Remember that this was an and in between them. So when we're done shading, our answers should be the overlap. It should be shaded in between these two values. Now our negative 2, we can estimate here. 6/5, you're just going to have to estimate that. It's 1 1/5. So you don't have to put all of the numbers on the number line. You can just label it as 6/5. We know it's larger than the negative 2, so it's going to be to the right of it. So now when I graph it, my first one is that my k values are less than 6/5. So I need an open point at 6/5, and I would be shading everything to the left. But I also need my k values to be bigger than negative 2. So that's starting at negative 2 with an open point and shading to the right. So my shading should be in between those two values because it was an and. Okay. Next example, we have 2w minus 1 inside the absolute value is less than 11. Okay. Again, it's a less than sign, so this is an and statement. So our inequalities split into 2w minus 1 is less than 11, and 2w minus 1 is greater than negative 11. Okay, so the second inequality, remember you're flipping the inequality sign and the sign on the number. Now you're just solving them both. So I'm adding 1. 2w is less than 12. Divide both sides by 2. So you get that w is less than 6. That's one of the two answers. You still have to solve the other one. Add 1 to both sides. You get 2w is greater than negative 10. Divide both sides by 2. So w is greater than negative 5. Again, this was an and statement. So when we're done graphing, our shading should be in between our 6 and our negative 5. So I'm putting a negative 5 on my number line, 6 on my number line. They are both just the less than or just the greater than symbol, so I just need open points. Neither one of them have the equal to sign underneath, so they're open points, and the shading is in between those two values. Okay, Next examples, if you notice, these are both greater than symbols. So instead of saying greater than, we say great or. So both of these have an or in between your two answers, which means your answers, when you graph them, should be going opposite directions. So I'm going to split this into two equations. My x minus 5 could be greater than or equal to 7, or x minus 5, I have to flip the inequality sign and change the sign on the number, so it becomes less than or equal to -7. Once you make that switch, then it's just solving both of these equations, and they're both just a one-step equation to solve. You're going to add 5 to both sides. Now, when you graph these two answers, remember that they should be going opposite directions, so check and make sure that that's what happens. I'm dealing with a -2 and a 12, so I'm putting my -2 on my number line and a +12. Obviously, the -2 should be on the left side compared to the 12, since it's negative. All of my answers for the -2 are supposed to be less than or equal to -2, so it's a solid point at -2. And if all of my answers are less than it, then I am going to the left. Then x is greater than or equal to +12. So solid point at 12, since it has the equal sign underneath. And all of my answers are greater than or equal to it, so that means I'm shading to the right. And our answers are shaded in opposite directions, so we graphed it correctly. Next up, we have the absolute value of x plus 3 is greater than 8. Okay, so I'm going to put all the work up here for it, and then you can just go through and follow the steps. But it's exactly the same setup as the first one. Okay, so I'm not going to talk through it. I'm just going to put the work there, and then you can check it. Okay, so you should get that x is greater than 5 or x is less than -11. Okay, now in this one, you have to make sure that you are isolating the absolute value first. And this is the same thing that we did with the equations. We cannot split into two unless the absolute value is by itself. So we need to get this p plus 4 by itself first. So in order to do that, you first need to take this -6 and add it to the other side. Remember, if we're moving it to the other side of the equation, you have to do the opposite. So instead of a -6, we're adding 6 to both sides. That's going to give me the absolute value of p plus 4 is greater than or equal to, and now -5 plus 6 gives us a +1. Now, this can be split into two separate equations to solve. Okay? Again, I'm going to put the work up there, and then you can follow through with it. This is the same exact steps as any of the other ones. Okay? It's greater than or equal to, so it's an or inequality.